Hi, hello everybody. So this is the chapter 9 or topic 9.1 as I call it here, dealing with exponential functions. Your workbook calls it exponential and log functions from section 26. Now, so far we have been dealing mostly with polynomial functions, which is very different from an exponential or log function. Now in 9.1, we're only going to be talking about exponential functions. And exponential functions are functions, as you see here, where the variable is in the exponent. Which is very different from, for example, a polynomial function, a quadratic function such as x squared plus 2x plus 3, where the variable is in the base. So these functions have the variable in the exponent. Okay, the number that you see here, in this case 3, it's called the base, and the variable is called the exponent. Now these exponential functions, they have a specific format. The number that is to be the base has to be a positive number greater than 0 but not 1. The reason it's not 1 is because when we have 1 to the power of x, if you remember from properties of exponents, that value never changes. So it's just a straight line and it doesn't qualify as an exponential function. Now I will show you the graph of an exponential functions right here shortly. You have it in the workbook. But for example, take a look at problem 26.1, asking which of the following are exponential functions. So everything that has a variable in the exponent is an exponential function. So h of x is as an exponential function, g of x is as an exponential function, and z of x is not an exponential function. Even though in this case the variable is in the exponent, the base must be a number greater than 0. So z of x is out, and so is f of x. So cannot be 1. H and g are good cases of exponential functions. So these are very common in many fields. And we'll see an example here in this section for the case where the base is a number bigger than 1, the function is increasing. Don't worry, we don't have to graph this function in our course, but it helps to see exactly what's happening to the function. So, and you can see here, in the table, even though with small variations of x, the function grows very quickly for the cases where the base is greater than 1. So this is called an increasing function or increasing exponential function, where the base is greater than 1. Remember, the base cannot be 1 or it cannot be negative. For the cases where the base is less than 1, such as 1/2, but remember, it's still positive, we have what we called a decreasing function. Okay, here's a decreasing function from left to right. And same as before, for very small values of x increasing, the function decreases very rapidly. So this is customary of exponential functions. They either grow very fast or decay very fast. The very first application that, type of problem, actually, I should say, that we have to be able to solve is a basic substitution problem, as you have here in 26.2. So you will be given some information dealing with an exponential function, and you are going to be asked, what is the value of that function at some point in time? And all that we have to do here is make a substitution. So for example, let's take a look at this case, even though it's worked here. So a car is depreciating according to the formula. This is the formula, where X is the age of the car in years. And you are now asked the following question: what is the value of the car when it's 5 years old? Well, if this is the function representing the value of the car, and X is the age of the car in years, and you want to know what is the value of the car when the car is 5 years old, all we have to do is replace this variable X with the number 5, as you can see right here. And we should be able to get this. So this is a calculator problem, and I'm going to show you here. So here is my calculator. And let's clear that. And all I need to do is make sure that I enter this information correctly. And I'm going to show you here how to do it. 32,000 times 1.96. To get the exponential part, you will use this symbol on the calculator. I will open parentheses to make sure that I don't make a mistake. The minus that you need to put is not the operation minus, it's this minus 0.04 times 5, close, enter. 2797 point, in my case, it's 40, but in the workbook, they've rounded up. Okay, so this is the first type of problem that you will see where we have to evaluate the function at a particular point in time, which only requires us to make a substitution into the formula and use the calculator. Okay, this is a similar problem. 26.3, the amount of money spent in a shopping mall increases according to the formula. This is the formula, where X is the number of hours spent in a mall, provided that this takes place. And we need to find the average amount spent after 2 hours and a half. Well, if this is the function, and I'm going to write it over here, 42.2, let's write this thing here. 42.2, I think it's 139. 2x. So this is the amount of money spent in the mall, and we want to know the amount spent after 2.5 hours. Well, all that we have to do is evaluate the function at 2.5. This is all we have to do. So this is the substitution part. And now we are at the calculator part. You will type everything here into the calculator, and the calculator will do the job for us. So 42.2 times 1.39 raised to, maybe we better put the parentheses just to make sure, 2 times 2.5. It's very easy to make a mistake in these problems, so we suggest that you are very, very careful with this. So the answer we get is 218.97. And obviously this is dollar amount. So this is $218.97 approximately. Okay, so these problems at first are very straightforward. We are given the formula. We are going to be given a specific time where we have to evaluate the function. We make the substitution, we use the calculator. That's basically it for this first type of problem that you will see on an exam or the final. Now, we do have one specific application dealing with exponential functions, and these are the very basic type of financial applications that we see commonly used in the field of finance. And we are going to see two types of basic formulas. These are the formulas that we're going to use to calculate the final amount A in an account, in an investment account that is receiving interest after some point in time. So there's two basic formulas. One is for periodic compounding of money or compounding interest, periodic compounding interest. And the second one is for continuous compounding interest. So how do we know the difference? Well, we are going to use the first one when something specific is said about how often the money is computed. I'll give you an example. The second one is going to be used only when the problem specifically uses the word continuous in it. So when you're reading the problem, and it's a problem about finding the amount of money in a particular account, you are going to use the second formula, this one right here, if the problem uses the word continuous. So in this case, must use the word continuous. So the problem that you are reading, that you're working on, must have the word compounded continuous. If it doesn't, we'll use this formula. If it does, we'll use this one. So these are problems that deal with the amount of money in an account. The variable A stands for final accumulated amount in the account. P is the principal or the initial amount that somebody puts in the account. R is the rate of return as a percentage per year. So this is how much money you're getting in your investment with the bank, with the broker, etc. The T is the time that you invested the money for in months, weeks, years, so on and so forth. We'll see a specific case. And N is the number of compounding periods. And I'm going to discuss what this is because it only applies to the periodic compounding. So as you can see here in this formula, there is no N. N only appears in this formula here. Okay, so let's take a look at the example here in the workbook. So here is the first formula, which I call the periodic compounding. This is where N exists. And this is the other formula when you have continuous compounding. Now we'll discuss specifically what this means. So for example, let's take a look at 26.6 first. You have 7,000 to invest in an account that will pay you 7.5% per year. Here is the main thing, compounded continuously. As soon as you read this word, you know this is the formula you have to use. And the question, how much will your investment be worth after 10 years? So they want to know the final amount in your account, which is A. A is final amount, P is the principal or the initial amount, R is the rate of return, T is the time invested. So once we collected all the data, all we have to do is use the correct formula. P, principal initial amount. I will show you what this E is. R, rate of return. As a percentage, notice that you are going to divide this value by 100. And T, number of years that you're investing for. Once you have this, the calculator will find the final answer. And let me show you here on the calculator. 7,000 times the E now is the following E, as you see right here, on top of the natural log, EX. So second, E, I am going to open parentheses because I don't want to make a mistake, 0.0725 times 10. And we'll get $14,453.11, or approximately 12, as you see here in the workbook. Okay, so these are for problems that say compounded continuously. You are to use the second formula. If the problem doesn't say compounded continuously, like this one, let's take a look, 26.5, you have 10,000 to invest in an account that will pay you 6.5% interest per year, compounded quarterly. It didn't say compounded continuously, so I have to use this formula here. How much will investment be worth after 15 years? So I already know I have to use this formula because the word continuously is not in here. So I am solving for A, the final amount. I know P, the initial amount, 10,000. I know R, 6.5%, which is 0.065. I know T, time, 15 years. And what is N? N is the number of periods we're going to compound in. Now, and that's going to depend on this word right here. So this is going to be one of the possible scenarios as you see here. Semi-annually means twice a year, so N is 2. Quarterly means 4 times a year, so N will be 4. Monthly means 12 times a year, so N is 12. Weekly, 52 times a year, N is 52. Daily, 365 days a year, or 365 for N. If the problem just says compounded annually, N would be 1. Okay, it's not included in the table, but just in case if it says that, N would be 1. So in this case, the problem says compounded quarterly. Well, quarterly means 4 times or 1 quarter, 4 times a year. So N will be 4. So when you use this formula, you are going to set it up so that N is 4, as you see over here. Once this is set up with the value substituted, all you have to do again is use the calculator and find the final amount. Let's do it here so that you can see 10,000 times, I'm going to open parentheses here, 1 plus 0.065 divided by 4, close parentheses, raise, because it's an exponent, and I'm going to put another parenthesis here, 4 times 15, which I know it's 60. So if you want to write 60 here, that's also fine. And I should get the value, $26,304 and approximately 71 cents. Okay, so once you have this information on a piece of paper, you just use this on the calculator to get your final answer. These problems are very short. The main important thing is making sure that you enter these values corrected on the calculator. So that would be the difference between you getting a problem completely correct or partially correct. So if this was a question on the exam where you have to show work, these 2 lines would be sufficient. I don't need to see anything else. You do not have to memorize these formulas for the final exam, because if the question on the final requires it, we'll give it to you. Okay. So let's see 2 problems. I'm going to do 2 problems here. One dealing with periodic compounding and the other dealing with continuous compounding. Okay, so let's take a look at 26.7. So let's see if I can copy this and put it on whiteboard. Yes, so that's good. I can do that. So let's see. You have 5,000 to invest in an account that will pay you 8.75% interest per year, compounded monthly. So because there is no compounded continuously, I know I'm going to have to use this formula. This is the formula we have to use. And all I need to do now is make sure that I know each of the variables and how to find it. So how much will investment be worth after 8 years? So I'm looking for A again. I know what P is. This is the initial amount, is $5,000. I know my R, which is 8.75% interest. I know T, which is 8 years, and I know N because it's compounded monthly. There are 12 months in a year, N is 12. So let's see. 5,000 for my initial investment. 8.75 divided by 100 is 0.085. And 12 months. N is 12, T is 8. So this is my problem. And all I have to do now is use the calculator to get the answer. So let's do it here again. So 5,000 times parentheses 1 plus 0.085 divided by 12, close parentheses, raise, and I need to do 12 times 8, which I know is 96, so I can write 96 here immediately, or you can write 12 times 8. That's fine. And my answer is 9,845. Point approximately 76 cents. Okay, so these problems, like I said, take about 2 lines. You have to know which function you're going to use. In this case, the word was monthly, so I'm going to use the periodic formula, not the continuous formula. I will substitute the values, now use the calculator to find my final answer. That's all we have to do for this type of problem. Now let's do one more. Problem 26.10. I'm going to copy here and I'm going to put it on the whiteboard. And the problem, notice that the problem is very similar, but now it's going to say something else. It's going to say something different. You have 8,000 to invest in an account that will pay you 4.2% interest per year, compounded continuously. So this is the formula now that looks like this. Because of the word continuously. Notice there is no N. How much will your investment be worth after 10 years? So we have to find P, which we know to be 8,000. We have to find R, which we know to be 4.2% per year, which we're going to write it as a decimal. And we need to know T, which in this case is 10 years. So we'll make the substitution. R 0.042 times 10. Once we have this, we go to the calculator. There's nothing else to do. We're not going to do these problems manually. So 8,000 times the E that we need, as I mentioned before, is this E above the natural log right here, e to the x. So we need to click second, natural log for E. Now open parentheses, 0.042 times 10. Close parentheses, enter, and we'll get the answer 12,175.69. I think. Let's confirm. Yes, 0.69. Okay, so again, like I said, these problems are just 2 lines. We've realized that we needed to use the continuous formula because of the word continuously. If the problem has the word continuously, we'll use this formula. Otherwise, we use the periodic form. So these problems are very straightforward. It is likely that you'll see them on the final exam. You do not have to memorize this formula or the other formula because it will be given to you.